So each day that we do EOC review, are we ready? Are we ready? Each day that we do EOC review, we're going to review specific units, and I'm going to give you guys pointers for those specific units. So there's some pointers I'm going to give you that work for all of the units, and then there's some pointers I'm going to give you that are going to be based on specific types of math, okay? This first unit, the pointers are going to be like lots of units they'll be helpful with, just because it's the first unit that we're doing. And then after that, it'll be like more specific to the unit. So today we're going to do unit 1 and 2, and this is the only day we're going to do unit 1 and 2. Like after this, we're done with unit 1 and 2. Okay. So if you were to look at, actually, hold on. If you were to look at Google Classroom, let me move this up. I'll show you guys how I'm planning out our review. I'm trying to make it in a pacing so it's not too overwhelming, but today we're going to do unit 1 and 2. Tomorrow's going to be unit 3. Wednesday's unit 4 and 5. On Thursday, we have a benchmark. That's not my choice. I'm being forced into it, so I apologize that you guys are doing another one of those tests. And then Friday is unit 6. So I'm trying to make it so we don't have to do 2 units every day. And then we slow down next week and start doing mixed reviews, so that it'll be like everything all together and you can kind of practice that stuff, like how it looks when it's all together. It starts getting a little bit frustrating around unit 6, unit 7, because that's where we can't fake the math anymore. We actually have to remember it because those were the geometry units. But the first couple of units, I will put up answer keys so you can kind of check your answers. And if you are curious to know how the math should have been done, you'll be able to see it. But I do not want you to do the math the way it should have been done. I want you to cheat using Desmos. Got it? So we are officially done learning math. We are now into cheater mode. Got it? We are no longer doing the long way. We are no longer showing our work. We are now officially we are using Desmos to cheat the system and not to remember anything and to be lazy. That's the purpose of what we're doing from here on out. Okay, so your guys' exam is on the Wednesday, I think, the 31st. So not the beginning of exams, but it's like in the middle, kind of. Okay, so the first problem, there are a lot of problems like this where they ask you to solve an equation of some sort. And so they give you 2 functions. They give you f of x over here is an absolute value function, and they give you g of x, and they want you to solve where f of x equals g of x, and they want you to find the x values. So anytime you solve an equation, you're going to graph the 2 equations as 2 different lines, and you're going to see where they cross. That's all you're going to do. So we're going to graph f of x equals absolute value of x minus 4 plus 2. So on Desmos, and the absolute value, that straight vertical line is right above your enter key. You're going to hit shift and then the line above the enter key. And you can put the f of x in there, but you don't have to. So I'm going to put x minus 4 with a plus 2 on the outside. And then I'm going to hit for my second line, I'm going to type in g of x, which is 3x minus 4. So notice I didn't put the f of x and I didn't put the g of x because you don't need to. And then I'm just going to see where they cross. I'll click this point right here, and the x coordinate is the answer. So they cross at 2.5, so the answer is 2.5. All right, now I'm going to show you something that you cannot do on the test. The reason you cannot do it is because the Desmos that is on the test will not let you do this. So if you type it in like this Desmos will give you an answer, but this is not the same as the testing Desmos. The testing Desmos will not show you anything here. Okay, so do not type this in this way. Don't practice it like this because the testing version of Desmos will not give you answers the same way. So here, if we were doing it, we could just zoom in and be like, oh, the answer is 2.5. The testing version of Desmos will not graph anything for you. It won't give you the answer. So we always graph, it'll just have a vertical. This version of Desmos will put a vertical answer, a vertical line where the answer is. The testing version of Desmos does not do that. This is the only thing I have found, like the only difference between regular Desmos and testing Desmos. So as long as you take the right side of the equation and put it down on a second line, what I have found is you'll be able to solve it every time. Okay, let's try another one. So we're going to go down to number 3 and do the same thing. So type in the left side. It says, state the solutions to the equation where h of x equals k of x. So we're going to type in h of x on the left side and k of x on the right side. It doesn't really matter which one you type first. To get x to the third, you're going to hit Shift 6. Shift 6. That's how you get that up arrow. To do your division sign, you can hit Shift and then the question, well, not Shift, the question mark key will get your division sign. What you'll end up finding as you use Desmos to do every problem is that this test feels a lot more like a typing practice than it does like actual math. And that's kind of nice because then you just end up getting all the answers pretty easily. So there are 3 answers to this problem. And all you have to do is just click on all of them. So it crosses here, there's 1 answer, 2 answers, 3 answers. The x value is always the answer. Now here they're asking you to round to the nearest hundredth. How many decimal places is that? 2. So we're going to write down 2 decimal places. On the test, you will be allowed to use Desmos as well as your graphing calculator. And I have told the people doing the test that my students are used to using graphing calculators, and I want you guys to be able to use them. So I'm pretty sure we're going to make sure that they are in the room. So I'll show you guys what your paper should look like. This is what I should see on your paper. Okay, we're going to jump over to number 9. So number 9 requires that you remember a little bit of math, but you can also use Desmos to cheat it. So this is going to be a new strategy. So this tells you that f of x is x squared minus 6x plus 2. And then they ask you to find f of x plus 3. And what I might do is I might pull up the actual assignment for you guys. I printed this really small so I wouldn't waste paper. So it might be helpful on your Chromebook to just like have the assignment pulled up, and I'll upload this in a second. Just so that if there's something where you can't read the font because it's too small, then you can have it in a bigger size up here. So that is x plus 3 right there, not a minus. I know it looks like a minus on your paper. Okay, so it says find f of x plus 3. So if you guys remember what this means, it just means to take the x out and put an x plus 3 in for the x instead. So we're going to put an x plus 3 right here, and we're going to put an x plus 3 right here, and we're going to put an x plus 3 right here. And what we're going to do with this is probably my favorite technique. And this is the technique that is going to get you, I don't know, like 2 full letter grades on your EOC, because this is used the most often. Okay. So what we're going to do is we're going to put the x plus 3s in here. So I'm going to say x plus 3 squared minus 6 times x plus 3 plus 2. And I'm going to stop there. I'm not going to do any math. What I'm going to do is I'm going to graph this. And whenever I'm trying to see if an answer matches my answer, I just have to graph all the answer choices, and whichever one matches my answer, that's the right one. I don't actually have to solve anything, okay? So I'm going to graph the answer that I know is supposed to be. And what they wanted me to do is they wanted me to write this twice and FOIL it out and distribute that and then combine like terms and do all the mathy stuff, but we don't have to do that. We're just going to type this in and graph it, and then graph all of the answer choices and see which one matches. Okay, so I'm going to go ahead and type in the x plus 3 squared minus 6 times x plus 3 plus 2. Okay, so this is the graph that we're going to match. And then we're going to start typing in the answer choices. So the answer choices are x squared plus 17. And since that has a plus 17, the graph shifted up 17. That's why you can't see it. It's all the way up there. So that one is definitely not the correct answer. So you can X out of it, or if you want to turn it off, you can turn that answer off by clicking over here. It'll just make it not graph. X squared minus 7. X squared minus 7. And if you look, we just found the right answer. I can tell because they're graphing right on top of each other. I don't have to check any of the other answers. I already know this is the right one. Now you can keep checking answers to make sure nothing else ends up being the same, but you're not going to find it. This is going to be the right answer. So we just got that answer number 2 is the correct answer for that problem. Now that method that I just did of graphing the answer choices to see which one matches the problem, that is going to get more than half of your problems right, probably. Okay, just based on the way that they phrase the questions. Anytime they say what's equivalent to this problem, what's another form of this answer, simplify this, anything like that, all you have to do is graph the answers, and then that's how you'll know which one's right. Okay, go ahead and turn the page. That answer is also the answer for number 11 because I accidentally put that one twice. Okay. Let's see. So let's try number 18. So number 18 says, which function is equivalent to this? If it says which one is equivalent, that means we can graph the problem and graph the answer choices, and we'll know which one is the correct answer. So let's go ahead and try that new method we just learned. So I'm going to graph the problem. The problem is y equals x squared minus 6x plus 10. So that's the problem. And now I'm going to graph the answer choices until I find the answer choice that matches and graphs on top of that parabola. So x plus 3 squared minus 1. That's not the right answer. X minus 3 squared plus 1. That is the right answer. Does that make sense? Yep. Okay. And then the nice thing is you can feel good about the answers because they're not like close to something. They are actually there. It is like right on top of it. So you know it's right. Okay. So the reason I plug stuff in for the x's on this one is because this said f of x equals, and this said f of x plus 3. So it was telling me to put something in for x. This one was just saying, here's an equation, find something equivalent. Yeah. Yeah. Okay. Here's another cool thing that Desmos can do. So it says, which function represents the graph that has x-intercepts at -3 and 2 and passes through the point 3, 12. So one cool thing about Desmos is you can graph an individual point. So if we want to graph -3, an x-intercept of -3, that's the point -3, 0. If we want to graph an x-intercept of 2, that's the point 2, 0. We also want to graph 3, 12. So what we can do to see which answer is right, we can graph all 3 of these points. And then once we have these 3 points graphed, then we can graph the answer choices and see which answer choice goes through all of those points. So I'm going to go to Desmos. No, it's all calculator active. Yeah. So I'm going to go here on Desmos. I'm going to type in these points. So -3, 0, and there's -3, 0 right there. +2, 0, and +3, 12. And 3, 12 is kind of up high on my graph, so I'm going to have to kind of zoom out, make it smaller. There's 3, 12. And then once I have those 3 points graphed, I can go ahead and start typing in my answer choices. So go ahead and take a moment, type in your answer choices, and let's see which one is correct. It'll go through all the dots. So I've heard some people say it. What's the answer? C? Okay, so if we type in 2, x plus 3, x minus 2, that goes through all 3 of the points. Yep. Okay. All right. Okay, another one that I would like to show you is number 21. So let's go over to number 21. Actually, I want to check on something first before I do that. So I'm going to have you guys, let's see. Go ahead and try number 8. I want you guys to try number 8 and then try number 6. And while you guys are doing that, I'm going to see if there's a trick that I've learned on Desmos in the last year that might work on number 21. Just a little hint about some vocabulary that's going to be helpful for number 6. When it says the function, anytime it says the function, it's talking about the y coordinate. Because when they say like this equation would be like y equals something or f of x equals something, so you'd say the function equals absolute value of x plus 4 minus 3 or absolute value of x minus 3 minus 4, something like that. The function equals something. So the function is the y coordinate. So they're just saying, where is the y coordinate positive? That's all they're asking. A reminder for part C, we've talked about this before, but it's been a while. What is the absolute minimum of this function? We usually used minimums and maximums as 2 points, X and Y. But just a reminder, if they don't use 2 points or 2 coordinates, there's 2 ways they can ask the question. They can ask a where question, and that means they're talking about the X coordinate, or they can ask a what question, and that means they're talking about the Y coordinate. So when they say what is the absolute minimum, that means they're asking for the Y coordinate of the lowest point. What is the lowest point? The Y coordinate there. Okay, I want to jump back to what was that problem? 21. Because I had learned something about Desmos that is very cool that I didn't know that Desmos did before. Yeah. So this is something pretty cool that Desmos does. So in this problem, they talk about f of x. They said f of x is x squared. They talk about h of x. They said h of x is 4x. And then down here, they ask you to plug some stuff into f of x. They ask you to plug some stuff into h of x. And it starts to get more confusing. There's another problem that's similar to this where you can't use this method on it, and I'll kind of explain why. But I'm going to show you guys how you can do this problem in Desmos and kind of make it easier on yourself. So we're going to type in first on Desmos what f of x is and what h of x is. So I'm going to type in f of x is x squared, and I'm actually going to type in the f of x because I'm telling Desmos what the name of the function is. So I'm saying the name f of x is x squared, the name h of x is 4x. And then what I'm going to do is I'm going to say, I don't need g of x for the next one because g of x is not a name that's being used in the problem. It's just them naming the result something. But then they tell us that the name f has negative 2x plugged in. So I'm going to say the name f has negative 2x plugged in. And then I'm going to say the name h has 1/2 x plugged in. And then we're going to divide it by 2. And you guys see how when I typed that in, something got graphed? Okay, that's my answer for the problem. So I'm going to go back. These are not my answers. These are just names of specific functions that got used somewhere else. The red, this one right here, it's probably a different color for yours. This one is the actual answer. And this is going to match up with one of my answer choices. Okay. So now that I've typed these, I'm going to go and I'm going to type my answer choices and see which one matches with that. It's B, 4x to the third. Okay. So 4x to the third. Yep, that's definitely it. Yeah, you're good. Okay. All right, now the one that I want to show you that doesn't quite work that way is number 4. Can somebody tell me why number 4 does not work that way? What's different about number 4? Yeah, they use an A. And the one thing about Desmos is it likes to use X as the input. It doesn't like to use anything else. So I'm going to show you what happens if we type in like 3A plus 2. Desmos doesn't graph it. It asks you if you want to put a slider, and then it lets you plug in different values for A, and it tells you what it equals if you plug in those different values for A. So I'm going to work on, I have an idea for how we can do that one. But I'm going to work on that one and I'll come back to it in a little bit and I'll let you guys know what I figure out. Because I still want to cheat on that one and make it easy for you guys. So for a little bit, I'm going to ask you guys to work on problems 1 through 21. That's what we're going to work on right now. And then once it's been about 10 or 15 minutes, probably about 10 minutes, because it's 1:10 right now. Once it's been about 10 minutes, then I'll come back and I'll talk to you about that problem. And then we'll start looking at the ones that have inverses. Sound good? Okay. So, and start to flag problems that you're unsure of. Okay. All right. Okay, let's look at the front page and look at the ones that are the word problems. These say that you're writing an absolute value inequality, absolute value inequality, or absolute value equation. And they're all kind of done the same way. And this is a concept that we skipped to give us more time on things that were more difficult. So the way that these are written is you have an absolute value. X is what you're solving for. And you say the difference between X and your goal number. And then you say that it's less by what you can vary by. And I'll explain using this problem. So it says you're asked to buy some decorative pumpkins to bring to a Halloween party. The small pumpkins are sold in bags, listing the weight as 1.2 pounds. Now, when you guys are sold products, do you think that every single, like if they say that something is 18 ounces or whatever, do you think that every single product is exactly 18.000 ounces, like perfectly on the dot? Probably not. We've all been in science class and we know that when we're doing like science experiments, the decimals don't usually work out perfectly, right? In math class, the decimals are perfect, but in science class and like reality, the real world stuff, the decimals are never perfect. So 1.2 is the goal, but we know that the actual decimal is going to be a little bit off the goal. So the clerk tells you that the weight varies by less than 0.15 pounds. So the goal here would be the 1.2 pounds. The amount you can vary is the 0.15 pounds. So this is how those absolute value inequalities get written. So if we try writing the next one, we're going to have X minus, this number is going to be your goal, less than, and then this number is going to be how much you can vary from the goal by. It says, you left your wallet in the car. A friend is texting you to go to the movies. You will need $12.95 for a ticket. You think you've got 20 in your wallet, give or take $5. Write and solve an absolute value inequality. So what's the goal for how much money you have in your wallet, and how much could you vary from that amount by? What's the goal for how much we have in our wallet? 20. And how much could it vary by? 5. So the $12.95 didn't matter for the problem. It was extra details. But the goal for how much they thought they had in their wallet was a $20 bill, or maybe 2 10s, maybe a 10 and 2 5, something like that. So they were hoping they had $20 in their wallet, but give or take $5. All right. Over for this one, it says an absolute value equation this time. So it's going to be a similar setup. We're still going to have our goal here. We're still going to have how much it can vary by. The only difference is it's going to be an equal sign instead of the inequality sign. So the recommended temperature for serving hot cream soups is 195 degrees plus or minus 5 degrees. Write and solve an absolute value equation. So what is the goal? 195, and then how much can you vary by? 5. Okay. So these, we did not do an actual worksheet for that concept. We didn't learn that day because it was a pretty easy concept and I wanted to spend our time doing other things. Okay, we're gonna go back to number 4 because I thought it was possible maybe to just use X instead of A and then do the problem the same way we did the other one, and it turns out that actually works. But I wanted to check it before I showed you guys how to do it. So we have 3 different names for functions in this problem. We have m of x, we have p of x, and then we actually have t of x being a combination of the two. So we're going to type those names into Desmos first so that Desmos knows what we're talking about. And then once Desmos knows what we're talking about, then we're going to tell Desmos, okay, but plug in 3a plus 2, but we're not going to use a because Desmos doesn't like a. We're going to use x. We're going to tell Desmos to plug in 3x plus 2. So let's go ahead and plug in those 3 names for Desmos so that Desmos knows who we're talking about. So we're going to type in m of x is the first name, and m of x represents absolute value of 4 minus x. The second name is p of x, which represents x plus 2. And the third name is t of x, which represents 4 times m of x minus 2 times p of x. You shouldn't be talking because I just figured this out, which means you definitely didn't know it. All right. So we've got those 3 names typed in. Now I'm going to turn all 3 of those graphs off because all of those were just me telling Desmos how to name things. None of those were the answer. Okay. So the thing that we are trying to figure out is we are trying to figure out what t of 3a plus 2 is, but Desmos doesn't like a, so we're going to use x's. So I'm going to go in the problem and I'm going to write 3x plus 2, and I'm going to put x's in here because when I type all these answer choices to see which answer is right, I'm not going to use a's. I'm going to use x's. Okay. So first I'm going to type t of 3x plus 2 in. And you'll know that you did this correctly if Desmos doesn't think that it's nonsense. So I'm going to show you one that it would think is nonsense. If I did k of 3x plus 2, 3x, hold on, k of 3x plus 2, Desmos is like, cool, should I add a slider? What you want me to do with that k? It's not graphing anything, okay? If I do t of 3x plus 2, Desmos is going to graph it because I defined it as something. Does that make sense? So there is an answer on the screen right now because it's really something. Now we can go through and we can start graphing those answer choices and see which one is going to match up with this answer perfectly. So 4, absolute value, 6 minus 3x minus 6x minus 8, not the first one. Not the second one. Not the third one. Oh, and then if you look at the fourth one, matches up perfectly. Okay. How do you guys feel about that? Make sense? Yes? Okay. All right, we're gonna flip to the next unit, which starts on problem 22. And with this unit, you might be mad once you realize how much easier these inverse problems are using Desmos. So this problem says, here's the inverse function. What was the original function? So does anyone remember there's one very first step you have to do to find an inverse? Yeah, switch the X and Y. Switch X and Y. And then after that was the hard part. After that, you had to do all the inverse operations. If something was added, you had to subtract it. If something was multiplied, you had to divide it. If something was squared, you had to square root it. If something was log base 5, you had to base 5 it. There were all sorts of things you had to do, and you had to do them in the correct order to come up with the final answer that was your inverse function. The nice thing about Desmos is that once you switch the X and Y, you're done. That's it. Because technically, once you switch the X and Y, you have found the inverse. The rest of it is just making it look correct. Does that make sense? But in Desmos, your stuff doesn't have to look correct for you to know what the answer is. It just has to be the same, okay? So here, we know that f of x, that's technically y. So here's technically my y. So if I want to find the inverse, or this is the inverse really. So if I want to find the original function, then I say, well, they must have traded the x and y to find the inverse. So all I'm going to do is I'm going to trade the x and y back. So I'm going to say x equals -3/4 y plus 2. This must be equivalent to my original function. And then all I'm going to do is I'm going to graph this. I'm going to graph my answers and see which one's the same. Okay? So I trade the x and y, and then I see which one matches up. So I'm going to go ahead and get out of all of these. Let's delete those all. Now, if you have changed your window, let's say you like zoomed out a ton. I just learned this recently, so I want to show you guys. If you've zoomed out a ton and things are wonky on your Desmos, all you have to do is click the home button and it goes back to normal. I don't know if you guys knew that, but I did not, so it's cool. I don't know if it clears that. I think you have to maybe press X, but it does make your screen go back to normal, which is nice. Yeah. Okay, so I'm going to type in x equals -3/4 y plus 2. I missed my equal sign. Let me fix that. Equals, there we go. So that is my original function. Now all I have to do is type in the other functions and see which one matches. And you can type in the f of x if you want. Here, I'm going to show you guys what happens, because Desmos, when you name something, Desmos can get confused. So 4/3 x minus 8/3. Okay, so that one is not the answer. The first one is not the answer. 3/4 x minus 2. Oh, it's having no problem. Okay. -4/3 x plus 8/3. Oh, there we go. So this third one matches perfectly. So the answer is number 2. So for anything that says find the inverse, literally all you have to do is trade the x and y and graph. That's it. Okay, so our goal for today is to finish as many problems in this packet as we can. Tomorrow is a little bit more simple of a day because we only have 1 unit, not 2, but we are going to try to do as many of these problems. Now, from now to the end of 5th period, I want you guys to send me flag problems and send them to me on Remind, because I can make a video going over any more problems you want me to put in a video, so that you could get help at home if you need it. Okay. Yeah, I still use Remind. So text me if there are problems that you would like to make it in video form. All right.